Hello everyone. Today we are going to see about laser. First we will see about what is the difference between ordinary light and laser light. So as we know that ordinary light is a polychromatic light, less intense, and it is less directional. Whereas the laser light is monochromatic, highly directional, and it is having very high intensity and it is coherent too. So first we will see about what are the characteristics of laser. First and foremost important properties, it is having high directionality, high intensity, highly monochromatic, and high coherent. Ordinary light spreads in all directions and its angular spread is 1 meter per meter. So that is why it is less directional. Whereas laser is highly directional and angular spread is 1 mm per meter. And ordinary light spreads in all directions and intensity reaching the target is very less. That is why it is a very less intense, and the intensity of laser beam reaching the target is of high intense beam. And if you are taking a helium neon laser, 1 milliwatt power of helium neon laser appears to be brighter than the sunlight. Laser light is highly monochromatic and the wavelength is single, that means single color. Whereas ordinary light like mercury vapor lamp, many wavelengths of light are emitted. And important characteristics of laser beam is coherence. The wave trains of same frequency are in phase. That is, the radiations given out is in mutual agreement not only in phase but also in direction of emission and polarization. Thus, it is a coherent beam. Due to high coherence in nature, it results in extremely high power. That is why laser beams are very much useful in material processing works. So we'll summarize what is the difference between laser and ordinary light. Ordinary light is the angular spread is more and they are not directional, it is less intense, it is not a coherent beam and it is not in phase, and the radiations are polychromatic. The example of ordinary light is sunlight, mercury vapor lamp. Whereas the laser beam, the angular spread is less, they are highly directional and it is highly intense. It is a coherent beam and is in phase. The radiations are monochromatic. So helium neon laser, CO2 laser, argon laser, we can take the example of this. There are two types of coherence, temporal and spatial coherence. What is the difference between temporal and spatial coherence? The measure of the correlation between the phases of a wave at different points along the direction of wave propagation is nothing but temporal coherence. Whereas the measure of correlation between the phases of a wave at different points transverse to the direction of propagation is known as the spatial coherence. So these two are very much important in the laser concepts. And when the radiation interacts with the matter, three types of atomic transitions will take place. One is induced absorption, spontaneous emission, and stimulated emission. So what is stimulated absorption? The atom which is in the ground state E1 will go to the excited state E2 by inducement. H nu is the energy of a photon. So by absorbing the energy h nu of a photon, the atom in the ground state E1 will go to the energy state E2 by inducement. This is called stimulated absorption. Another process is spontaneous emission. The atom which is in the excited state E2 will come to the ground state E1 spontaneously by emitting one photon of energy h nu. This is known as spontaneous emission. Whereas the atom which is in the excited state E2 will come to the ground state E1 with the emission of two photons by inducement. By absorbing a photon of energy h nu, it will come to the ground state E1, that is called stimulated emission. So during stimulated emission process, two photons are emitted. Whereas in spontaneous emission, only one photon is emitted. So the photons which are emitted in spontaneous emission is random in direction and it is not coherent and it is not monochromatic. Whereas in stimulated emission process, the photons which are emitted are highly directional and they are highly monochromatic and they are coherent. They are all in phase, they are having the same energy and same frequency. So in detail we'll see about it. Induced absorption. So here E1 is the ground state and E2 is the excited state. Photon of energy h nu will come and incident on the atom in the ground state E1. Atom in the ground state E1 absorbs the incident photon and gets excited. Because of that excitation, it will go to the higher energy state E2. So this process is called induced absorption. So there are two types of emission as I have mentioned earlier. One is a spontaneous emission and stimulated emission. So as we know that what is the emission? Atom in the excited state will not stay there for a long time. It will come to the ground state by emitting a photon of energy. So such an emission takes place by these two methods, spontaneous emission and stimulated emission. So spontaneous emission. So E1 is a ground state and E2 is the excited state. So already we have excited the atom from E1 to E2 by stimulated absorption process. The atom in the excited state E2 will return to the ground state E1 by emitting a photon of energy h nu spontaneously without any external triggering. So this emission process is called as a spontaneous emission process. So during the spontaneous emission process, only one photon is emitted in random direction and it is independent of the incident radiation. Whereas in stimulated emission process, the atom in the excited state return to the ground state by external triggering. So there is an inducement of photon, so thereby emitting a photon of energy equal to energy of incident photon. So during this process, we are having two photons. It results in two photons which are having same energy, phase difference and of same directionality. So the atom which is in the higher energy level will come to the ground state spontaneously. So the atom can remain in the excited state for about 10 power minus 7 seconds. We can say that lifetime of atom electron in the excited state is about 10 power minus 7 seconds. So within that 10 power minus 7 seconds, it has to come to the ground state. Otherwise, if it is not coming to the ground state, we have to induce that atom to come to the ground state. So in between that ground state and excited state, in one of the excited state, the atom can remain for longer time. The lifetime is about 10 power minus 3 seconds. So that type of excited energy states are called as a metastable energy states. Now we will see what is the difference between stimulated and spontaneous emission. We know what is a stimulated emission. So the atom in excited state induced to return to the ground state, thereby resulting in two photons of same frequency and energy is called stimulated emission. In spontaneous emission process, atom in the excited state return to the ground state, thereby emitting a photon without any external inducement is called spontaneous emission. In stimulated emission process, emitted photons move in the same direction and are highly directional. Radiation is highly intense, monochromatic and coherent. The photons are in phase and there is a constant phase difference between the photons in stimulated emission process. Whereas in spontaneous emission, the emitted photons move in all directions and are random. Radiation is less intense and is incoherent. The photons are not in phase, so there is no phase relationship between them. Now we will see what is the principle of laser action. Consider many number of atoms in the excited state. So the photons emitted by the stimulated emission process having same frequency, energy and phase as the incident photon. So it results in two photons of similar properties. So these two photons induce stimulated emission of two atoms in the excited state, resulting in 4 photons. Again, these 4 photons induce 4 more atoms and give rise to 8 photons. So due to stimulated emission process, the photons in the excited state will come to the ground state. Again, it will be multiplied by several process. So this is the principle of laser action. So this leads to intense beam of laser. Now we will see what is population inversion. So generally in spontaneous emission is more predominant in the optical region. For our laser action to occur, we have to increase the number of coherent photons. So to increase the number of photons, stimulated emission process should dominate over spontaneous emission process. To achieve this, an artificial condition is called population inversion is necessary. So this is the first one is the normal population, whereas in normal population number of atoms in the ground state is more than that of number of atoms in the excited state. So this is a normal population. So we have to invert this population to achieve this lasing action. So that artificial condition is called population inversion. So in population inversion, number of atoms in the excited state should be more than that of number of atoms in the ground state. So here you can see that in a ground state we are having 1 atom, and in the excited state we are having 5 atoms. Like that we have to invert the population of atoms in the structure. So we'll define what is a population inversion. So now consider N1 is the number of atoms in the ground state and N2 is the number of atoms in the excited state. If N1 is greater than N2, there is a more chance for absorption to take place. If N2 is greater than N1, more chance for stimulated emission to take place. So number of atoms in the excited state is increased by some means. So that is the state of achieving great number of atoms in the excited state compared to the ground state atoms is called as a population inversion. Thank you.